So now that we've had a chance to do a basic introduction of operations management and go through the history, what's really important is to consider how we measure that, how we objectively measure whether or not we're making our processes better. So again, the fundamental definition of operations management is really the way we transform inputs into outputs, and that value creating process in the middle, which is transforming those inputs into outputs, is our operations. And that's what we want to get better at. That's where we're going to focus over the course of the next 14 weeks, different methods and approaches that we can take to try to improve our ability to take those inputs and turn them into outputs. So one of the fundamental ways that we can quantify or measure that is productivity. So productivity is simply the ratio of outputs divided by the inputs. So if we think about productivity, there's two ways that we can improve it. So we can increase or improve our productivity by either reducing the amount of labor hours or the total dollar amount or our capital overhead. So all of those resources, we can try to reduce that and produce the same amount of a good or a service. That would be one way to improve productivity. The second way would be to keep everything the same in terms of our capital expenditures, our labor hours, keep that all the same, but try to find ways with the resources that we're currently using to produce even more goods and more services. So those are the two ways we can improve productivity. And the way that we calculate it, again, is because we're looking at that ratio of outputs divided by inputs. That's going to be our measure of process improvement. And something I think is really interesting is that aside from the fact that this is, if you are in an operations management position, you're for your own sake and for the company's sake, you want to be able to quantify and measure this. But as an economy, this is also how we measure how we're getting better and how we're moving forward in all of our different industries. On average, the United States increases productivity by about 2.5% annually, and that'll vary depending on the sector that you're in. But what that boils down to is that if we continue at improving productivity across industries at about 2.5% annually, that's going to mean we're going to be able to double the wealth of the United States about every 30 years. So again, it goes beyond just trying to make these seemingly small incremental improvements, but that really has a snowball effect when you look at every organization, iteratively trying to make improvements to productivity. That all boils down to then how much improvement is happening in the industry, how competition is increasing, and when we look at that as a whole, it has major implications for our economy. Okay, so getting down to how do we actually calculate productivity? So one way is labor productivity. So this is also called single factor productivity because we're not taking into account all the different types of resources we're using. We're only looking at labor. So if we are only looking at single factor productivity, we're looking at the number of units produced or number of services rendered divided by the total number of labor hours used. So in this simple example, if we have 1,000 widgets that we're producing over an 8-hour shift, and we've got 250 man hours that are going into creating those widgets on that 8-hour shift, that's going to boil down to 4 units or widgets per labor hour. So the other way that we can look at productivity, which is a more robust, more holistic view of productivity, is something called multi-factor productivity. And that's where you're bringing in those labor dollars, all of the materials, those resources that you're using to transform those inputs into outputs, your energy, your capital expenditures, all of those overhead dollars, and you're calculating what your output is based on the total number of dollars that you're putting into your system to create that output. So this is also known as total factor productivity. So an example that we can use for productivity, we're going to do both single factor and multi-factor. So this is basically a revision of the example that's in the text to something that is meaningful for me. So if we look at the overhead in an operating room, one of the more generally accepted metrics is that for every single operating room, it costs about $62 per minute to have that operating room up and running. And that takes into account all of the equipment, all of the energy, and all of the man hours, those labor resources for anesthesiologists, surgeons, for patient care techs and nurses. So if you look at how much those individuals are getting paid to be there and to support the surgical procedures in an operating room and all of the equipment that goes along with it, it's about $62 per minute. And so if we just take an average sized facility that says maybe has 20 operating rooms in their entire surgical suite, that boils down to about $1,300 per minute, every single minute that OR is running during the day. So it becomes really important that we start to look at these metrics. We understand what that overhead amount is. We realize how much money we're spending by having our facility up and running, even for a single minute. Because I think if you can boil it down to that level, that again, that gives you the impetus to go through and try to figure out how can you scientifically make improvements to either, again, increase the number of surgical cases that you can do in a day, or kind of reduce some of those resources or those capital expenditures, again, to improve your productivity. Okay, so example aside, so we're looking at a surgical suite. Let's say in the system, as is the current way it runs, you've got a staff of 6 workers working for an 8-hour shift, and the total payroll for those 6 individuals would boil down to $6,400 a day. Now, let's say in that operating room, you could do eight cases per day. And when you take into account the energy resources, the capital, all of those equipment supplies, that it would cost about $4,000 a day to have that operating room operational. So if we were just to look at it from a single factor perspective, so our labor productivity, we would basically just take our output, which is 8 cases per day. We would divide that by 48 labor hours, which is, again, those 6 workers multiplied by 8 hours a day. And that would give us a labor productivity of about 0.167 cases per labor hour. So this may seem like it doesn't really make a whole lot of sense, right? That seems kind of like an abstract way to measure something, but you'll see as we go through the calculations why it's important to do this. So again, if we were just to break it out, for every single labor hour, you could accomplish 0.167 cases. So let's say that the operating room decided to use one of the new Da Vinci surgical machines. So if you haven't heard about it, it's a really neat, it's equipment that is used in a lot of ORs now, where instead of doing kind of full-blown surgical procedures, now it's a robot that will guide and assist the surgeon to do the surgery, so that they can do it laparoscopically, and you can get that patient through that surgical procedure faster and get them actually home. You can oftentimes do cases now as outpatient procedures, where in the past the patient would have to stay because it was a more intense surgery. But now with the support of this Da Vinci machine, you're able to do 14 cases per day in that operating room. But you also have some additional overhead expenditures because of this new medical technology. So now we'll say that our overhead is about $8,000 per day. So if we were just looking at single factor productivity, our new labor productivity would be 14 cases per day divided by that same 48 labor hours, right? That's 6 workers times 8 hours a day. So now if we're just, again, looking at labor productivity or single factor productivity, that would boil down to 0.292 cases per labor hour. Okay, so we can see that with this new technology, we do, if just looking at single factor productivity, we do certainly have some increases in productivity. Now let's look at it from a multi-factor standpoint, because if we're just looking at it from labor hour standpoint, that again doesn't take into account the fact that we're now using this medical technology that is doubling our overhead in the operating room each day. So if we look at it from a multi-factor productivity standpoint, the current way what they were doing it, the procedures before the Da Vinci machine, you had 8 cases per day, and you were dividing that by your payroll cost of $6,400 a day plus that overhead of $4,000 a day, and that would give you a multi-factor productivity of 0.00077 cases per dollar, right? So for every dollar, you're not getting a whole lot. It costs a lot to make one of these cases happen. If we look at it from a multi-factor productivity standpoint now with a new Da Vinci machine, so you've got 14 cases that you can accomplish in a given day, and divide that by now your resource dollars, so $6,400 a day for payroll, that stays the same, but now your overhead is $8,000 a day. So that's going to change your multi-factor productivity now to 0.00097 cases per dollar. So it's interesting, if you look at the difference between that single factor and that multi-factor productivity, if we go back to the single factor labor productivity, it really looks like there's a substantial increase in productivity. But again, once we take into account all of the factors, including that overhead, we're still seeing some increases, but they're not nearly to the extent that we saw them before. So as we go through and as we do these productivity calculations, it's always important to boil down those numbers in terms of the percent increase. So just a reminder, because I find that even though you probably did this in grade school and in high school in terms of how to find a percent increase or change, that if we haven't done it in a number of years, sometimes we forget. So whenever we calculate a percent increase, we take that final last value. So in the case of the multi-factor productivity, right, that was 0.00097 minus that initial value of 0.00077, and divide that all by, again, that original multi-factor productivity value of 0.00077. Multiply it by 100%, and you guys should get about a 20% increase. So if you have any questions as we go through these calculations, please don't hesitate to reach out.